All right. Hey, folks, how we all doing? Okay, so we've been starting to work through this idea of trigonometry for a little bit. And we've been starting off and we've been playing with what is meant by a right triangle trig. And so we've been playing with that for a little bit. And we said that every right triangle trig is essentially every single trig has opposite, adjacent, and an hypotenuse. And we're dealing with the right triangles here. But what we're going to do today is we're going to look at something else. For instance, this value, this radius, can eventually be spun. If we lock one point in, it can be spun around that point of origin. And if you do that, you can kind of see that it eventually makes a circle. So what we want to do there is we want to kind of start to look at this a little bit and say, well, wait a second. What if our trig was a little bit more than just this idea? Let's see, I can't try to center this a little bit better here. That'll be okay. There we go. Yeah, it's close enough. What if we were to take that triangle and spin it all the way around and we start playing with this idea of circles? So when we start looking at it, we start thinking, all right, let's deal with this edge of a circle, that circumference of a circle. And we learned back in Integrated 2 or geometry that there were a couple of different ways that we could deal with the outside of a circle. And that's going to be essentially what we play with today, dealing with the outside of a circle. And then over the next couple of days, we'll bring it back to this idea of triangles here. That may have been not the best straight line. There we go, that's a little better. So the first way we learned to deal with the outside of a circle was the measurement, or the degree measure. And if we start this and we're looking at the degree measure, we could start on one point, this x-axis, and we go all the way around. We say, well, let's let that be at 0 degrees. And if we go all the way around, that would be 360 degrees. At the same, so say let's take this angle right here, this measure right here, halfway around it. Halfway around this circle could have been, well, if this is a right angle, this would have been 90 degrees because the x and the y axis form a right angle. So halfway around, that'd be about 45 degrees or so. So the arc measure on this part right here would have been 45 degrees. But we learned something back in circles as well. We learned that there's an angle that lies at the center of a circle. We call that the central angle. And that central angle is equal to the arc measure. So this right here, that would be our central angle. So that central angle then is going to be equal to 360. Oh, I lied. That central angle is going to be equal to 45 degrees. The other way that we learned to measure angles or measure the outside is by the circumference. And if you guys remember, the circumference is 2 pi r. So based upon however long my radius is, it will determine how long I'm going around the edge of a circle. We call that the arc length. But what if, just for the sake of argument here, I let my radius be equal to 1? So if I started right here and I didn't go anywhere, my arc length would be 0. But then as I go all the way around with a radius of 1, my circumference, or the entire arc length, would be equal to 2 pi times 1, which is 2 pi. This right here is like the sloppiest 2 of all time. There you go, 2 pi. Well, just like we were able to measure that central angle in degrees, math people thought, what if we could measure it in terms of like this idea of an angle dictated by the radius? And so they said, well, if we did that, another way we could then call it, we wouldn't call it a radius angle, but we could call it an angle in terms of radians. The way you know that you're dealing with degrees is a degree will always have, if you're dealing with an angle in degree, it's always going to have a degree sign. So whatever the number is, there's going to be a degree sign up here. If you're dealing with a radian, a lot of you guys say, oh, it's when there's pi. No, and you'll see what I mean by that here in a second. No, it's not that if it's in terms of pi, it's just there's no degree sign. So a degree will be a number with a degree sign. A radian is just a number, doesn't have to have a pi with it, just a number with no degree sign. Well, here's what math people saw. They said, well, okay, well, if we can go 360 degrees, degrees, they relate to 360 degrees all the way around a circle. Well, radians, this idea of radians is a circumference. If we go all the way around the circumference of a unit circle, the radian value, the angle in terms of that radius, the radian value would be 2 pi. And so what math people did is they said, well, maybe there's a way to convert. Sometimes maybe we want to be in degrees. Sometimes maybe we want to be in terms of this radian value. And you guys at first, a lot of times are going to be like, wait a minute, I like degrees. Why do we have to learn another way? Math people, we actually prefer this radian way. More your physics and applied, they like degrees, but if you're doing theoretical math, we kind of like radians. Next year in AP Calculus, that's pretty much all we do is radians. We don't ever use degrees. So we could set up a proportion to be able to convert between degrees and radians. So degrees, 360 degrees, and radians is out of 2 pi. Or if you want to think of it another way, both those numbers are divided by 180. We could say degrees out of 180 degrees equals the radian value out of pi. And so if we were to cross multiply and we move our pi to this side over here, we can create a way to convert our radians from degrees. Turns out that the radian value is always going to be whatever the degree value is times pi over 180. If we convert the other way, we find out that the degree is always 180 degrees over pi times the radians. And so we can go back and forth between an angle in terms of degrees or an angle in radian form. So an angle in degree form or an angle in radian form. And so let's take a look at real quickly that one angle we had that was 45 degrees. That's in degree form. We could turn it into radian form if we wanted to. And here's how we do it. In place, we'd come over here and say, okay, well, we want to put it in terms of radians. So I'm going to take this pi over 180. And I'm going to multiply it by 45 degrees. So 45 over 180, that's going to be 1/4 times pi, or what we say it is, pi over 4. So 45 degrees then, that's the degree form. It's the same angle as pi over 4 in radian form. And so we can convert back and forth now between these two different ways to evaluate a degree, or evaluate a central angle, evaluate an angle. An angle can be in terms of degrees, or it can be in terms of radians. And this is what I'm talking about pi. You're going to notice that most of our radian angles are going to have pi somewhere in it. For instance, say I give you the angle 60 degrees. And we're going to go to our notes here in a second. I just want to really make sure you guys understand how this conversion works. If I were to do 60 degrees, that'd be an angle like right here. So therefore, this degree up here, this arc measure would be 60 degrees. But there's probably a radian that it's also equal to. So why don't you guys pause the video and see if you can't convert 60 degrees into radians. All right, let's try it. So R is pi over 180 times 60. So that's the same thing as 1/3 times pi, which we would say then is pi over 3. So this angle right here, you could call it 60 degrees. You could also call it pi over 3. 60 degrees, that's the degree form. Pi over 3, that is the radian form. So using this idea, let's go ahead and take it to our notes now. We're going to be talking about various angles and eventually converting them between this degree and radian degree. So the first thing we want to look at is how do we go about taking angles and first sketching them. Now, when you sketch an angle, we'll come back to this conversion idea here in a second. When we sketch an angle, if I'm going in a positive direction, that means I'm spinning counterclockwise. I know it's going to sound kind of intuitive, but if I go in the opposite direction, that's going in a negative direction. That's how I'd get a negative angle. Now, I want you to think about this for a second. Back in when you guys were first learning how to plot points, didn't your teachers say that this was quadrant 1, quadrant 2, quadrant 3, and quadrant 4? Well, that idea is actually technically a trig idea. If we start here at 0 and we spin, we go first into this quadrant, then into quadrant 2, quadrant 3, and quadrant 4 while we're making that full circle. Now, remember, it's 360 degrees all the way around a circle. Or it's 2 pi if we're in radians all the way around a circle. So if we go over 360 degrees, this is where we're going to use spirals potentially to show just how many times we went. So first thing we're going to do here is we're going to start by sketching some angles. We're not going to sketch radians yet. We're just going to sketch some angles. Sketch them in degrees. So let's take 195 degrees. If I sketch it, when I go halfway, that would be, if it's 360 degrees is all the way, halfway would have been 180 degrees. A quarter of the way would have been 90 degrees. So every quarter turn is 90 degrees. We saw that integrated too as well when we were dealing with rotations. So another 90 would put me at 270 degrees, and you can kind of see how we get to 360. 90, 180, 270, 360. So I'm trying to go 195 degrees. Well, that's going to be just a little bit more. It's a little closer to 180 than it is to 275. So that would be where that angle is. Now, to let me see that that's where I'm stopping, I draw something that we call a terminal ray. That terminal ray means I'm going to terminate myself at 0, 0. That doesn't sound very good, terminate myself. And I'm going to draw it out. That means I'm going to stop right there. That's 195 degrees. Now, it's not the most accurate drawing. It's probably going to be a little bit closer up, but you know what? As long as it's relatively in the ballpark, we're good. So the negative means I'm going to spin clockwise. So I'm going 90, 180, negative 270, negative 360. So I went negative 360 degrees. That was a full circle. But if you notice, I'm not quite there yet. I got to keep going. And so if I go another negative 90, that's negative 450. So I got to keep going a little bit more. And I'm doing my arrow saying that's the direction I went. And then I draw my terminal ray. So don't think of the negative as a negative value. Think of it more as a direction. A positive angle is going counterclockwise. A negative angle is going clockwise. Think of it more in terms of a direction and not a value. Why don't you guys pause the video and see if you can't graph 845. All right, so let's see here. How did you guys do? You went 360 degrees. So you went all the way around. But we got to keep going here. We got to keep spinning. Just keep spinning. Just keep spinning. So you went another one. That's 720 degrees. By the way, if you notice this idea, 0 degrees, 360 degrees, 720 degrees, all these angles are in the same location. We'll talk about that in a second. Those are called coterminal angles. There's an infinite number of angles that lie in the same spot. So 90, if I go 360 more, 450 degrees and 90 degrees would be at the same spot. I'm still keep going here. So when I'm spinning around again, now I'm at another 90 degrees. So I went 2 360s and another 90. So this is now technically 810 degrees. So all three of these angles, 90, 450, and 810, all in the same location. They're coterminal angles, but I got to keep going a little bit more so I get to 845, which would be right about there. So I have my two spirals to show that I actually spiraled around. And there's my coterminal angle. So here's what I want you guys to try. What if instead of using, here we go. Instead of using degrees, what if we used radians? In other words, what if I gave you some other values? Like, what if I asked you to graph 3 pi over 4? How about if I ask you to graph 5 pi over 2? Let's do a negative 5 pi over 2. Now that we know that we can have radian angles as well. And what if, just for the sake of argument, I asked you to graph, how about 30 pi over 7? What do you think those would look like? So we're going to use the same idea here, but now we're going to use these fractions, these radians, to help us graph these. So I'm going to help you guys kind of set this up here so we can kind of see here. So we're starting at 0 radians. When we went all the way around, that was at 2 pi. So 0 and 2 pi, those are coterminal. They both end here at the x-axis. What if I only went halfway? So what's half of 2 pi? That'd be at 1 pi. So 0 to pi, another pi gives me 2 pi. Well, what's halfway between 0 and pi? Well, that's half a pi, or pi over 2. So 90 degrees is equal to pi over 2. These are the same thing. It's just one's in degrees, one's in radians. So 1 pi over 2, pi is 2 pi over 2. This would be 3 pi over 2. So I'm looking for 3 pi over 4. So this is like 0.5. 1/2 pi is 0.5 pi. Pi is 1 pi, and I'm looking for 0.75 pi. Well, that's going to be a little bit more. That's halfway between 0.5 pi and 1 pi. So 0.5 pi and 1 pi would be 3/4 pi. And there's my coterminal angle. Again, we're just getting this idea. We've learned that we can convert back and forth between degrees and radians. If I can sketch a degree, an angle in degrees, I should be able to sketch an angle in radians. So why don't you guys pause your video and see if you guys can actually sketch these two angles. Go for it. Okay, so little hint here. It helps when you're graphing these. So I know that I'm going 2 pi or negative 2 pi. That's a full circle. It helps when you're doing this if you look at the denominator and turn your 2 pi into something that has the same denominator. So 2 pi is the same thing as what over 2? It'd be 4 pi. So a complete rotation of 2 pi is the same thing as 1 pi. I'm sorry, as 4 pi over 2. So 2 pi equals 4 pi over 2. Whenever you're dealing with one of these, try to think of it in terms of your common denominator. Get a common denominator. So 5 pi over 2 in the negative direction. So if I go a complete circle, that's 4 pi over 2. That's a negative. So I went negative 4 pi over 2. I want to go one more pi over 2 to get negative 5 pi over 2. And if pi over 2 is 90 degrees, I'm going to go one more pi over 2 then to get my angle. And I know, guys, the angle using radians is going to take a little bit of time to get used to. It's really not too bad. All right, so now 2 pi. Notice my denominator here is a 7. So I want to have that be the same thing as 14 pi over 7. So a full rotation is 14 pi over 7. So here we go. 14 pi over 7. I'm going in a positive direction since it's a positive angle. I'm going to go again. That's 28 pi over 7. So over 7, this would be about 3.5 pi over 7 because that's half of my denominator. And that means pi is the same thing as 7 pi over 7. Right? If I've gone negative 28, or if I've gone 28 pi now over 7, because I did 2 full rotations, I only got 2 pi 7 more to go. And if this is 3.5, half a rotation is 3.5 over 7, I'm not going to go quite that far. I got to stop before I get there. So that would be 30 pi over 7. So the first thing we got to be able to do, friends, we got to be able to just kind of sketch a graph, be able to locate it. All right, and we can sketch the graph both in degrees and in radians. And if we keep going here, we find out that these angles can be, we can have multiple angles of the same one. And like we were saying, a complete rotation is 360 degrees. So if I want to find angles that are similar to each other, all I have to do is just keep adding or subtracting 360 degrees. So say I give you an angle in terms of degrees. Let's not use d anymore. Let's go ahead and use theta. You can tell it's degree again because it will have a degree sign. This idea of a coterminal angle means there's multiple angles that lie in the same location as this 380. So let me graph that real quickly. So if I do a full rotation, that's 360 degrees. And I've gone 360 and I go 20 more. That would be where that angle is. There's multiple angles that live on that idea. If I just keep adding 360 and subtracting 360, I will have angles that are in the same location as 380 degrees. That's those angles that are in the same location, different numbers, but same location, those are called coterminal angles. And the way we do it is we're going to add or subtract 360 degrees. The technical way to look at it is this. In degrees, I would add or subtract 360 degrees. And n is the number of rotations. If n is positive, that means I'm spinning in a positive direction. If n is negative, I'm spinning in a negative direction. So, why don't you guys pause the video and see if you can come up with an angle that is a positive coterminal angle to 380 degrees and an angle that is a negative coterminal angle to 380 degrees. All right, let's see how you did. If I want a positive angle, all I do, friends, is take my 380 and I'm going to add 360 to it. So if I add 360 to it, that's when n is 1, that's just a rotation. I end up with 740 degrees. So 740 degrees would be a positive coterminal angle to 380. If I want a negative one, then I'm going to subtract it from it. So 380 minus 360, that would be 20 degrees. Now hang on a second. A negative coterminal angle has to be negative. So this is not a negative coterminal angle. What this is another positive coterminal angle. If I want a negative coterminal angle, I'm going to have to keep subtracting until I get a negative value. So let's take that 20 and we're going to subtract 360 again. Again, it's 360 because I'm just spinning it around the circle. And I end up with negative 240 degrees. Now that would be a negative coterminal angle. And friends, we can also do the same thing with radians. Same thing with radians. Say I give you an angle like, let's say, let's make it a little tougher on you. Now we'll keep it basic. 7 pi over 5. If I wanted to find a positive and negative coterminal angle to it, on this one, instead of adding or subtracting 360, now I'm going to add or subtract 2 pi. N means N is the number of rotations or revolutions. Positive n's go in the positive way. Negative means I'm spinning it backwards. So if I want a positive value, if I want a positive coterminal angle, I'm going to keep adding 2 pi. I'm going to keep adding 2 pi until I get another positive value. Again, I can keep adding 2 pi over and over again until I get a positive value. Now, the one tricky part about these is you got to do a little bit with your, you got to do a little bit with having a common denominator. So 2 pi is the same thing as 10 pi over 5. So that means a positive coterminal angle would be 17 pi over 5. So if I wanted a negative coterminal angle, I would subtract. Why don't you guys pause the video and figure out what a negative coterminal angle would be to 7 pi over 5. All right, here we go. Negative coterminal angle. We take our 7 pi over 5. And now we are going to subtract 10 pi over 5. And if this number is not negative, then I keep subtracting until I end up with a negative value. So negative 3 pi over 5 would be a negative coterminal angle. It's an angle in the same location, but just different number of rotations. That's what we mean by coterminal. And down here, guys, you can kind of see on this conversion thing how we actually go about converting. So converting radians to degrees. So we said to do that, we take our radian value and we multiply it by 180 over pi, which we proved back on the last one, on that first screen before we started all this stuff. If I want to turn degrees into radians, I'm going to take pi over 180. I'm going to multiply it by the degree value. And it's a way for us to, again, convert radians into degrees and degrees into radians. So next up, we are going to do some conversions, friends. What I want you guys to do is I want you to sketch this angle, identify one positive negative angle in radians to 135 degrees. So we're first going to convert it. First put into radians. After that, sketch it. And then I want a positive and negative coterminal angle. And the value, the angle we're dealing with is 135 degrees. So we're going to put it all together. So why don't you guys go ahead and pause it and see what you guys can do. All right, here we go. Let's try it. I'm 135 degrees, and I'm going to turn it into radians. So for my radian value, I'm going to take that 135 degrees, and I'm going to multiply it by pi over 180 degrees. And friends, if we do that, we end up with 3/4 pi, or what we want to call it is 3 pi over 4. Hey, we did this angle earlier. 3 pi over 4. Okay, then you sketched it. So now once I convert it into radians, I'm doing everything in terms of pi. Okay, so let's think about it here. What do we know about pi? We went 0. We had pi over 2. That's half a pi. We had a full pi. We had 3 half a pies. And that led us back to 0, which is the same thing as 2 pi, because 0 and 2 pi, they're coterminal. So where would 3 pi over 4 be? Well, pi over 2 is 0.5 pi. Pi is 1 pi, and I'm looking for 0.75 pi. That is halfway between them. So it'll be right about here. Halfway between them. So there's 3 pi over 4. Now we wanted to find a positive and negative coterminal angle to 3 pi over 4. So if we're going to do coterminal angles, that means we are going to add and subtract 2 pi. I'm going to keep adding 2 pi until I get a positive angle, to get a positive coterminal angle. I'm going to keep subtracting 2 pi until I get a negative coterminal angle. So 3 pi over 4. Got to get a common denominator, so that means this will be 8 pi over 4. So a positive coterminal angle to 3 pi over 4 is 11 pi over 4. A negative coterminal angle, now we're going to subtract. So negative 3 pi over 4 minus 8 pi over 4. I don't know why I made that 3 negative. That's just a positive 3. Sorry about that, gang. So 3 pi over 4 minus 8 pi over 4, that would be a negative 5 pi over 4. Again, it's a negative value, so that's my negative coterminal angle. If it was still positive, I'd keep subtracting until I get a negative value. All right, friends. So the next one, let's have you guys try this one. We're going to convert from radians to degrees here. So we're going to go the opposite. Then you're going to sketch it. And then you're going to get one positive and one negative coterminal angle. Why don't you go ahead and pause the video and see what you guys can do. Go for it. Okay, let's see how you did. So I'm going to turn it into degrees. Okay, so I'm going to take my negative 11 pi over 12. And I'm going to multiply it by 180 degrees over pi. So 12 goes into 180 15 times. The pi's are going to cancel out. So 15 times 11, that'd be negative 165 degrees. So I'm going to go through now and I'm going to sketch negative 165 degrees. So let's see here. If I'm starting at 0, every quarter turn is 90 degrees, but since I'm going in negative direction, I'm going in negative 90, negative 180, and negative 270. And again, remember, the negative is not a value as it is more of a direction. The negative tells me I'm spinning clockwise. Positive tells me I'm spinning counterclockwise. All right, so here we go. Negative 165 degrees. Well, I'm going to 90. Going a little past that, but I'm not quite going to reach that negative 180 here. So there's my arc, and now I draw my coterminal angle. It doesn't have to be exact. And now I'm ready to go ahead and find out my positive and negative coterminal angles. So if I want a positive, I'm going to take negative 165, and I'm going to add 360 to it. Now, if my answer is still negative, I'm going to keep adding until I get a positive. So negative 165 plus 360, and friends, I would end up with 195 degrees. To get my negative coterminal angle, I'm going to take my negative 165 degrees, and I'm going to subtract 360 degrees from it. So we're taking a little time out today, friends, away from the sine, cosine stuff, because we got to be able to talk about what the lines should look like. Oh, I almost put 420 there. That should be 520. Or not lines, what the angles should look like. We got to understand this idea of all these circular angles. 460, there we go. All right, so we've learned to convert, we're sketching, we're getting positive and negative coterminal angles. We're just about done here, friends. And the last thing we have, friends, is we're dealing with complementary and supplementary angles. Now remember, we did complementary back in, this idea of complementary is back in integrated 1 and 2. There are two angles that add up to 90 degrees. Well, now they also add up to pi over 2 because 90 degrees is the same thing as pi over 2. Supplementary angles, those are two angles that add up to 180 degrees. Go back to integrated 1, integrated 2, or our geometry if that's where you went from. But now that we know that we also have radians, it could be equal to pi. So if you're ever asked to find a complementary or a supplementary angle, you're being asked to find it in terms of whatever it's given to you. So if your angle's in degrees, you're asked to find the complementary and supplementary angles in terms of degrees. If they're given to you in terms of pi, or radians, I'm sorry, then you're asked to find it in terms of radians. So this right here, here's our angle. We're going to go and try to figure out the supplementary angle and the complementary angle to pi over 12. Well, the complementary angle, they add up to pi over 2. So to figure out the complement, I'm going to subtract. So pi over 2 minus pi over 12. Now, for this, friends, our angles are always going to be positive. So our complementary angle, that's 6 pi over 12 minus pi over 12. So that complementary angle would be 5 pi over 12. It's a positive value, so we're good. That is the actual complement. If that was a negative value, then it wouldn't be a complement. Now we're going to go and figure out the supplementary angle. So this time, supplementary angles add up to pi. So I'm going to subtract pi over 12 from pi. So pi is the same thing as 12 pi over 12. So pi over 12 minus pi, 12 pi over 12 minus pi over 12 is 11 pi over 12. So 5 pi over 12 is the complement to pi over 12. And 11 pi over 12 is the supplement to pi over 12. Friends, why don't you guys go ahead and pause the video and figure out the complement and the supplement to these next two angles. Go for it. All right, obviously degrees are easier. So 90 degrees minus 83 degrees. Its complement is 7 degrees. The supplement are angles that add up to 180. So 180 minus 83, that would be 97. And over here, complement, pi over 2 minus 7 pi over 9. Got to get a common denominator. So 2 and 9, that denominator will be 18. So this will be 9 pi over 18 minus 14 pi over 18. And that would be negative 5 pi over 18. So in other words, there is no complement. And think of it this way, negative people are not usually quick to complement. No complement. What about a supplement? Supplementary angles add up to pi. So pi minus 7 pi over 9. So 9 pi over 9 minus 7 pi over 9 is 2 pi over 9. It does have a supplement. No complement, but it does have a supplement. All right, friends, so that takes care of this idea of angles and them being both in radians and degrees. Hopefully we have a little bit better idea of what a radian is. All right, so angles can be radians and degrees, and there can be infinite number of angles at a given location. Those are called coterminal angles. Okay? And then to a lesser point, we now know a little quick review on what complementary and supplementary angles are. So I'll see you guys in class, and we will talk more about this.